Hello, my name is Professor Raj Amritaraja, and I am chairing the UC Davis Electrical and Computer Engineering Undergraduate Curriculum Review Committee. This brief presentation will give an overview of the committee's activities, timeline, and the current state of the undergraduate curriculum in the department. The membership of the committee, including myself as the chair representing the circuits area, is Professor Al-Assad, representing computer engineering, Professor Hayat, representing physical electronics, Professor Lai, representing signals and systems, Professor Pham and Professor Billy Putnam, representing electromagnetics, our lecturer, Human Rashtian, and Margie Legrand, our outstanding undergraduate program coordinator. The charge of the committee is to perform a comprehensive review of both the electrical engineering and computer engineering four-year curriculum, recommend changes, and then implement those curriculum changes. And such changes could include the addition or removal of courses, the revision of course content or the number of units for a particular course, modification of the delivery methods, including hybrid and remote courses, project-based learning, etc., and any other ideas. And one of the reasons for creating this video is to solicit input on curriculum changes that our stakeholders, both inside and outside the department, would like to see. The timeline is over the next few years. So in this academic year, the department, through the work of this committee and discussion with faculty, is planning on converging on some proposed changes to the curriculum. Starting next year, academic year, we'll coordinate those changes at the department level to provide some proposals to the College of Engineering Review Committee, the Undergraduate Program Committee, which will review our proposed changes. And then those proposals will go to the Campus Committee on Courses on Instruction in the following academic year, 2022 to 2023, with the goal of implementing the new curriculum in the fall of 2023. Because of the accelerated timeline and the extended time required for program review, we are targeting incremental changes to the curriculum and not a radical redesign of our instructional delivery. So with that, let me summarize briefly our current curriculum. So we have two majors, electrical engineering and computer engineering. In electrical engineering, we have recommended 5 tracks, and these tracks are not they are not rigidly defined sequences of courses. They are recommendations for students who express an interest in a particular specialty area or subspecialty area of electrical engineering. The 5 tracks we currently have are analog electronics, communications control and signal processing, digital electronics, electromagnetics and wireless, and physical electronics. And again, these are suggested curriculum tracks. Many students, as they approach their upper division courses and are presented with a choice of many different electives, are unsure what to take. And so we have some recommended schedules along these 5 tracks to give the students an idea or suggestion for a set of courses and a sequence in which they should be taken. And then for computer engineering, we have a single recommended track. So in total, we have 6 recommended schedules that the students are exposed to. And again, these are purely recommendations. Individual students choose their courses based on their own interest, hopefully with input and advice from our undergraduate program coordinator as well as faculty. So what I'll do in the next few slides is go over the different recommended schedules, discuss the courses that are listed, and maybe mention some opportunities for possible revision of those courses. So let's start with the analog electronics recommended schedule for the electrical engineering major. And a lot of these lower division courses in the freshman and sophomore year are the same no matter what track or even across both majors. And so I've sort of highlighted here a couple of specific details. So as you know, sort of traditional for engineering curricula, the freshman sophomore year is heavily math and science based. And so where the students begin after in the freshman year, taking calculus, an engineering design introductory course, and then also our 1-unit Introduction to ECE course, which is started off as a seminar, but has now started to include a laboratory experience with students design and build using a microcontroller and some breadboards, some basic circuits to kind of expose them to the different topics or tracks even within electrical engineering. And then they continue again with calculus, with chemistry. They start our Introduction to Programming course, EEC 7, which utilizes the C language. And again, they're programming microcontrollers. And then by spring of the freshman year, they're starting calculus-based physics sequence, Physics 9A, which is mechanics. And we're also taking Engineering 6, which is another programming course, this one based on MATLAB, but also including some discussion of numerical computing topics and other higher level programming concepts compared to the introductory programming course in C. In the sophomore year, they continue with more advanced mathematics, vector analysis, linear algebra, and differential equations. In physics, they continue with fluids and thermo. And at the same time, we're recommending that they take the introductory circuits-based course. This is based primarily on passive elements and sources and so on. We don't introduce op amps typically in this course, we do it later. In winter quarter of their sophomore year, they're taking the physics version of electromagnetics, which also includes some circuits, and also our introductory course on digital systems, where they use project-based learning, building a robot and programming a microcontroller to have the robot follow sounds, where the sounds are detected using microphone circuits that the students themselves build and solder on protoboards and so on. And then by the end of the sophomore year, they're taking the last of the physics sequence, which focuses on special relativity and quantum. And then our introductory digital systems course, focusing on logic gates and other introductory digital concepts. Then in the junior and senior years, the students will focus on taking core classes in a variety of topics. For example, a second circuits course, an introduction to device physics, an introduction to electromagnetics. And then for students who want to continue on the analog circuits and electronics track, they will take our 2-core sequence on transistor level electronic circuits, as well as introductory signals and systems course, control systems, and probability and statistics. And then a new course that Professor Roshtian developed, we're recommending students take on power electronic circuits. Then in the senior year, and again, these are just suggestions, they're not requirements, students can follow up with more signals and systems, focusing on discrete time as opposed to continuous time in the introductory course, signals and communications, and then a senior design project. In this track, we're recommending the autonomous vehicle project, but they could take any of the multiple senior design courses that we offer. Then in winter, a course on communication electronics, PLLs, and et cetera. And then in the spring, concluding with more advanced device physics, maybe more control systems, and a course on digital integrated circuits. Now, briefly, I'll just mention that in comparing our curriculum with other UCs like UCLA and UCSD, there's some similarities and some differences. So one similarity is that UCSD, for example, has a extensive introductory course in the freshman year with significant laboratory experience. We are expanding EEC 1 to be more along those lines and increasing the number of units associated with the course. From our review of the UCLA curriculum, device physics has migrated somewhat into the sophomore year. And it's a possibility that we could, for example, replace the Physics 9D course, which does not really provide a lot of relevance for electrical engineers. Their coverage of quantum, I think, is focused on like developing the hydrogen atom as opposed to solid state physics. And so one possibility would be to migrate 140A into the lower division to expose the students to that topic earlier and remove the physics requirement. So that's one area of possible change. One challenge with moving some of these junior level courses into the sophomore year is that transfer students who are coming in at the junior year typically won't have exposure to those courses at their 2-year college. And so the question is, how do we accommodate the transfer students? And that's a question that would have to be addressed if we continue with the idea of moving some of our upper division courses further into the lower division. For the communications control and signal processing track, again, it's very similar to the analog circuits track. The main difference in the senior year, we're suggesting that the students potentially take an advanced digital systems course, another course on statistical communication, and given them a couple of different options on the senior design project course. One focused on machine learning and AI, which Professor Chua has been developing, along with Professor Akella. Another focused on microwave design that Professor Leo Liu has developed. For digital electronics, again, the first 3 years is quite similar, except that the second device physics course is brought in, as well as the advanced digital electronics course. And then the senior year, the students are encouraged to take a course on VLSI design, computer architecture, embedded systems, and then digital ICs, and possibly parallel computer architectures as well. So the digital electronic track has some overlap between the analog circuits track and the computer engineering track. For the electromagnetics track, again, both the introductory and the advanced 2-quarter sequence of E&M is suggested in the junior year, as well as the advanced device physics course. And then in the senior year, focusing on microwave systems, antennas, recommending the RF microwave senior design project, communication electronics, and so on. So kind of an overlap between analog circuits and signals and systems, with more of the electromagnetics thrown in. Physical electronics, again, this is focused on devices, both optical and photonic. Through the junior year, again, very similar to the other electrical engineering tracks, with the senior year being focused more on device fabrication, as well as integrated circuits and VLSI, and materials. Now, for computer engineering, the sequence is somewhat different compared to electrical engineering. So again, computer engineering is a separate major than electrical engineering. And within electrical engineering, we had these 5 recommended schedules or tracks based on student interest. Computer engineering is lumped into just the one major. The main difference is that a lot of the software-oriented courses computer engineering students are getting from the CS department to align more with the focus or emphasis or inclusion of software in the computer engineering major as opposed to the electrical engineering major. So they start off with the ECS, that's computer science, 3-quarter sequence on programming. The first quarter is ECS 336A, which can be taught using either Python or C. And this is one of the reasons for us creating our own introductory programming class, EEC7, which is exclusively focused on C, since we wanted our electrical engineers to learn C and learn it quickly in order to be successful with microcontroller programming and embedded systems. In the second quarter, in winter, the students will take the second CS course, which is going to focus on C and C++. And in the third quarter, the last CS course, which focuses on data structures and programming. Computer engineering follows the same physics sequence, except they don't take physics 9D, modern physics, and that requirement is replaced with an elective. And then in the upper division, less emphasis on circuits and more emphasis on algorithms and digital systems, all the way up to architecture, VLSI, digital IC design in the senior year, as well as embedded systems. So one thing you'll notice is that device physics is not a part of the recommended schedule for computer engineering. The reason is because of this course I've highlighted here, which we are offering for the first time this year and developed over the last summer and fall. EEC 111 is meant to combine elements of EEC 140A device physics, EEC 110A analog circuits, and a little bit of, and then emphasize digital circuit design at the transistor level. And so the reason we consolidated those topics into one course was to free up opportunities for computer engineering students, especially to have more technical electives available in their senior year. They were limited to, I believe, just one before, and now they have the opportunity to take 2 or 3. So that is the current status of our curriculum viewed through these recommended schedules that we give to students to help them make their decisions in their upper division courses. And we look forward to hearing your feedback on what curriculum changes make sense going forward. Thank you.